Everybody, yesterday we took a look at the sine law. Today we're going to take a look at cosine law. So not all triangles can be solved using sine law if we don't have a full ratio. And there are two specific types of triangles that we don't have enough information. First of all, side, side, side. When all we have are sides, obviously we don't have an angle to set up our sine law. The other way is when we have side, angle, side, where the angle is sandwiched between the two given sides, which means we don't have a full ratio here. We don't have a side. We don't have a full ratio here because we don't have an angle, and we don't have a full ratio here because we also don't have the angle. Okay, so those two specific types of triangles or given information, we have to use cosine law. So cosine law, to find a side, a squared equals b squared plus c squared minus 2bc cos of a, will help us find our side. If we want to find side b, we're going to take b squared is equal to our other two sides squared and added together, subtracting 2 times those sides times the cosine of b. For c, we would set it up again, the other two sides squared and added together, subtract those two sides times cos of c. And that's in the case of side, angle, side. And notice that those are the only pieces of information we have are the other two sides and the angle of the side we're looking for. So it kind of makes sense how we're going to set up that formula. If we were talking about triangle PQR, well again, doesn't matter what the label is, p squared is equal to the other two sides squared and added, subtract those two sides times 2 times the cos of angle P. Rearranging to solve for an angle. So if we want to solve for A, angle A, we want to isolate cos A. Rearrange this formula to get cos A all by itself. We notice that this is subtract. Well, we want to get to a positive cos A, so we're going to first of all move that whole chunk of information. We can't separate it right now because it's all one piece of information. We're going to take that over to the left. At the same time, we're going to bring our a squared over here. So we're going to have b squared plus c squared minus a squared. And now we can get rid of the 2bc that's with our cos of a by taking it over to the other side and dividing. So cos a is equal to b squared plus c squared minus a squared, all divided by 2 times b times c. So this is the formula for an angle. So just like that, if we had cos b, it's the other two sides squared and added, subtracting the square of that side over 2ac. So we can think about either remembering how to rearrange our side formula, or just remember what our angle formula is. So in general, a squared equals b squared plus c squared minus 2bc cos a. And for an angle, cos a equals b squared plus c squared minus a squared divided by 2bc. So looking at some examples. So first question, we're given triangle RST. We want to find side S. So we want to find this side over here. Well, we notice right away we have side, angle, side, which means automatically cosine law. So S squared equals other two sides squared and added, so r squared plus t squared minus 2rt cos s, and we can sub in appropriately. So R is 20, T is 10, and our angle is 40. So subbing that all in there, 20 squared plus 10 squared minus, and we can do this all in one step in our calculators, just making sure that we have brackets around that last portion, because BEDMAS tells us that that multiplication has to be done before we subtract. So we are going to now put this into the calculator. 20 squared plus 10 squared minus bracket 2 times 20 times 10 times cos 40. And we press equals. Notice that we get the answer here, which then needs to be square rooted. So s squared is equal to 193.58. Now we're going to square root that. When we do so, we get, rounding to one decimal place, 13.9 meters. Okay, so we know side S is equal to 13.9 meters. Second question here, we want to find our indicated angle, and our indicated angle is angle A. Again, right away we notice we have side, 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 so we can't use sine law. So we're going to set up our cosine law. Cos of A equals B squared plus C squared minus A squared over 2BC. Subbing in our numbers, we have 17 squared plus 14 squared minus 16 squared divided by 2 times 17 times 14. Now, putting this all into the calculator, we know this is going to be our cosine ratio. So when we do this, 17 squared plus 14 squared minus 16 squared equals, so we have an answer to the top, divided by bracket 2 times 17 times 14 end bracket equals. This is our ratio. So what we want to do is do our inverse cos, or cos to the negative 1, of the answer that we get here. And our answer that we got here was 0.481092, and we want to keep as many decimal places as possible so that we get as precise an answer as possible. So, rounding to the nearest degree, angle A is equal to 61 degrees. We want to keep at least 4, if not more, decimals. If we can do that all in one step in our calculator, all the better. Example number 3, we want to solve triangle IJK. So again, solve means to find everything that we don't know in that triangle. The first thing we always want to do is make sure that we draw our triangle. So we're going to sketch our triangle to start with. We know it's probably not to scale, and that's okay, but we want to see what we need to know and how we're going to get there. So triangle IJK, we don't know if it's a right angle triangle or not, so we can't use SOHCAHTOA. Side I across from angle I is 10.5. Side J across from angle J is 11.8. And side K is 12.5. So right away we notice we have side, side, side. We don't have any angles to work with at this point, so no sine law. So we're going to start with cos of angle I. And we're going to set it up. We know it's going to be j squared plus k squared minus I squared divided by 2jk. And subbing in our numbers, j is 11.8, k is 12.5, and I is 10.5. And we are going to do our inverse cos. So cos of I, finding our ratio first, 11.8 squared plus 12.5 squared minus 10.5 squared equals, divided by bracket 2 times 11.8 times 12.5, end bracket equals. And we should never get a cosine ratio greater than 1. If we do, then we know we've done something wrong and we need to go back and check it. So we get this decimal. We're going to do our inverse cos to find our angle, rounding to the nearest degree. We know that angle I is 51 degrees. We are still going to use our cosine law to find angle J. So this time we're going to have I squared plus k squared minus j squared over 2ik, which means that we're going to have 10.5 squared plus 12.5 squared minus 11.8 squared divided by 2 times 10.5 times 12.5. When we do that, we're going to get our decimal. And again, we're going to do our inverse cosine for that answer. If you need to do it in 2 steps, by all means. We're going to find J here is approximately 61 degrees, rounding to the nearest degree. And once we have 2 of these angles, we're going to find our third one by taking 180 minus 51 minus 61. We can do this because angle sum of a triangle theorem. So angle K is equal to 68 degrees. Quick therefore statement, stating everything that we have figured out here. Angle I is 51 degrees, making sure we put our units on here. Angle J is 61 degrees, and angle K is 68 degrees. Okay, so that's a quick review of our cosine law. Cosine law is basically our last resort. If it's a right angle triangle, we use SOHCAHTOA. Non-right angle triangle, we look for sine law first, a little easier to set up. And if we can't